Hey friends, this one may hurt. We've all been conditioned to say that we live on a globe that is bending away from us by 8 inches per mile squared. Truthfully, this is going to hurt the globe as much more than it's going to hurt you, but you may take a little time to come to terms with this. Or maybe I've got the maths completely wrong. You can tell me in the comments section what you think and whether you have anything to add to this conversation. Okay, so typically we are, all of us, and I'm definitely a part of this, I'm not making any exceptions for being a part of possibly pushing yet more propaganda on behalf of this strange world we live in. Everybody knows this. Here, let's say that's my center, and that's, we know, 4,000 miles. My ink is running out, that's just perfect timing. How's that looking? This is all very low tech, as you have come to expect. So it's a 4,000 mile radius and 24,900 and something, but I'm just going to work on 900 miles. Yep, and that's the circumference. That's the distance around on the outside. We typically accept that when I leave, let's call this the North Pole and let's call this the equator for the sake of this conversation. When I leave the equator and travel to, when I leave the North Pole and travel to the equator, yep, hope you can get all of that in. When I leave North Pole, travel to the equator, I have to travel over the skin of the spherical, and I'm going to work on a pure spherical model. I'm not interested in getting too bogged down in oblate sphericity. That would create a complication that sometimes would mean that the figure was either more or less in terms of the amount of curvature drop. Because this is what I'm interested in here, is this 4,000 miles of drop. Okay? So in order to travel this distance here, it is 1/4 of the entire circumference, therefore somewhere in the region of 6,250 miles. So I'm going to travel 6,250 miles over the skin of the earth, and in so doing I'm going to drop down by 4,000 miles. Now typically we say that it's 8 inches in the mile squared, and exponentially it's dropping down more and more rapidly as we travel around the globe. I have an issue now with this, and my issue is this. If you were to envisage, this is my starting point, if you would envisage my aircraft, I'm going to fly, my dog wants my attention. If you were to envisage my aircraft flying from this point A to this point B, are we going to leave airport A and get to cruising altitude, and for the first mile descend 8 inches, the second mile 32 inches, and by the 10th mile have descended 66 feet, and by the 100th mile we would have descended 6,666 feet. Now, for the purposes of this demonstration, I want you to think about what would be the aircraft's experience if that were the case at the 99th mile marker. So 99 times 99, I've got a little calculator operating right here, old school. 99 times 99 multiplied by the 8 inches and divided by the 12 to give us the feet would be 6,534 feet. And we all know that the 100th mile is 6,666 feet or thereabouts. So if I subtract that I'm left with 132 feet. In other words, if from the point of the observer watching the aircraft go away from me, we've always argued that in the first mile it's going to descend 8 inches. It could be the water, it could be a ship over water, but remember, if a plane is flying around the globe, then it is flying at 30,000 feet and always curving in exact alignment at 30,000 feet with the skin or with the shape of the sphere. So my argument to self is that the aircraft can't be making 8-inch descent in the first mile, a 32-inch descent in the second mile, down to 66 feet. Okay, I know it's 32 minus 8, so it would be 24 inches in the second mile. But you get my point, that by the 99th mile, it would have descended 6,500 odd feet. But in the next mile, the 99th to 100th mile, it must descend 132 feet in order to work with the maths that we're given. We're told that the 8 inches per mile squared works quite well up until 1,000 miles. Now, again, that's like, well, this is a maths formula that we say hypothetically works, but in reality, does it? And would that be the case, that in the 99th mile, the aircraft is now going to have to make a descent of 132 feet? Let's just do, just for the sake of interest, the 499th mile, okay, times 499 times 8 divide 12 is 166,000 feet. I'm just going to write that down here. 166k feet. That's the 499th mile. The 500th mile times 8 divide 12 is 166,000. I didn't make this up. 166,666.66 feet. In other words, and in simple terms, the 499th mile marker to the 500th mile marker is going to require my aircraft to descend by 666 feet. Now, that's an awful lot of descent when you consider that it's meant to be descending evenly and equally at all times, because it is actually traveling around, in my example, a perfect sphere, maintaining the same altitude above the surface. It can't be getting, because I'm standing at point A, it can't be getting steeper and steeper and steeper when you're at towards point B. It must be the same amount. Yes, it means that at this point here in the journey, let's say it's at the sort of 1:30 position, between the 1 and the 2 of a clock. If it's there, then yes, from my perspective, the angle that I'm looking at it is now 45 degrees, because eventually it'll be 90 degrees off my perpendicular. It'll be facing, relative to me, it would be facing down into the ground like that, and at this point it would be sort of halfway like that. So from my point, if I could see it at this distance, I would be able to see a plane's underbelly, kind of like that. So it is a lot steeper from me as opposed to when it was right near me. I accept that, but in terms of the aircraft's trajectory, then it needs to be an equal amount of downward bending in order to follow closely with the surface of the ball. So, if your friend was standing at the 499th mile marker and looking out towards the 500th mile marker, would your friend expect the aircraft to descend by 666 feet? Or would he say, no, the aircraft is only going to descend by 8 inches because it's only a mile between here and the next mile marker? And I think herein lies the trick and the deception with the 8 inches per mile squared, and that is that the steepness is not getting greater the further away from it. Yes, the amount that you descend obviously is going, because ultimately you're going to go down by 4,000 miles. But the rate at which you descend for each step, and let's just say each step is 1 mile, the rate at which you descend is going to be the same rate every one of these 4,000 steps. Well, it's 6,000 steps, 6,200 steps, 6,200 miles between here and here. So for each of those steps, I need to descend an equal amount. So what is that equal amount, I hear you shouting? Well, my friends, it's quite simple. And I'm going to show you that I've actually got something that should excite even the ballers. Look at this. I have a globe acquired especially for this. Now, to keep this simple, and because I've tried to explain this a couple of times now, I realize that, yes, well, it may be, can you see this? It may be 6,250 miles there, and 6,250 miles there, 6,250 miles, and 6,250 miles all the way back. So this is, obviously easily broken down into quadrants, but we know the radius is 4,000 miles. That's the accepted number. So the distance between the North Pole of this globe and the South Pole of this globe, if you were to drill a straight line and go through, would be 8,000 miles. So we can all agree that in order for someone to travel from here to here, they would have to descend 8,000 miles downwards. Whilst they're traveling 8,000 miles downwards, they have the luxury of traveling 1/2 of the circumference of our supposed globe. Now, our supposed globe is 24,900 miles in circumference, there or thereabouts. Divide that by 2, gives you, I'm not saying wrong with my maths, let's just clear that. 24,900 miles, divide that by 2, gives you 12,450 miles. We all agreed a moment ago, well, I hope we did, that to travel from here in the North Pole to here in the alleged South Pole is a drop of 8,000 miles, a vertical descent of 8,000 miles. I'm not troubling myself with everything being tipped at an edge, at 23 degrees and so on. I'm not troubling with any of that. I'm trying to keep this simple. We can get into some of the more nitty-gritty detail of that once we understand and unpick that the 8 inches per mile squared might have been designed to protect the globe. It might have been designed to minimize the truth about living on a globe of 24,900 miles in circumference and a radius of 4,000 miles. Does that make the diameter 8,000 miles? 8,000 miles divided by 12,450. Now I need to... 8,000 miles divided by 12,450 is 0.6425702 miles. In other words, for every mile you move over the skin of this perfect sphere, you're going to have to go down 0.6425702 miles. My friends, that's almost a kilometer of drop, descent, curvature for every mile that we travel. Just let that sink in for a few moments. Imagine the amount that we would say over just a small swimming pool, a lake, and even a mile marker, we would be able to immediately throw the globe onto the fire, which is really where it belongs, because it is so impossible to imagine that over such a short distance, yes, 6,000 miles, we have to descend 4,000 miles. And at 0.64 of a mile of descent per mile of going outwards, or travel over the surface, it makes it absolutely impossible. And I think the 8 inches per mile squared, if I can add, I think what I think now is that the 8 inches per mile squared was given to us as a means of pushing into the far distance the amount of curvature that we should be able to see. Pushing it far enough out so that it would require a P900 or something like that to be able to start to make observations that made sense. Pushing it out so far that we would think, okay, yes, it's possible. This is why we can still see a ship at 3, 4, 5 miles away, is because there's only 20, 30, 40, 80 inches, and that can easily be obfuscated with swells and ocular kind of effects and distortions and so on. But 0.6 of a mile is about a kilometer. It's about 1,000 meters for every mile. Guys, that's so much curvature that everything should be rushing, falling off the edge of our vision within a very, very short space of time, within less than a mile, because to lose something that was, let's just say we were to halve the mile. I haven't thought about the maths on this, but if we were to say half a mile, and again, it's about saying that the amount of curve for the globe should be equal at all points. If you imagine your plane is flying with the skin, or your ship is at water level, and this is just a water ball, then it is going to be traveling an equal amount outwards as downwards, no matter where you start from, no matter where you view it from. And I come back to the point that if my ship traveled away from me at 8 inches in the mile squared, my friend standing at the 99th mile marker would observe 130 feet would observe 8 inches of curvature, either of the ship coming towards it or away from it, because we'd say a mile around me is only 8 inches down. But from my perspective, I would say, no, the ship is descending 132 miles from the 9th mile to the 10th mile. 132 feet from the 9th mile to the 10th mile. And of course, that number becomes even more skewed, as I said earlier on. At the 499th mile to the 500th mile, I'm expecting my ship or plane to descend 666 feet over 1 mile. But of course, we know it's not going to do that if someone else was standing at that point, they would say, no, it's only going to go down 8 inches, because from my perspective, everything is only descending 8 inches. The reality is, friends, is that it has to be bending at an even amount, an equal amount, throughout the entirety of its travel, if it keeps the same elevation. This is a bombshell for me. It's only been a week or so that I've been thinking about this, and realizing why some of my sort of arguments with people about them saying, well, so if I was to travel a mile away from you, and my next mile is that I look out is only 8 inches, you're saying it's 32 inches down. This is where it gets confusing, and where it doesn't actually make sense to me anymore. The beautiful thing about this maths of 0.6425 miles of drop per mile of travel is that you can apply that maths to the entirety of the globe. As I showed here, I could take, what did we say that the globe was? 12,450 miles to the halfway point. So multiply my 6425 by 12,450, and you get 7,999.9989 miles. So it's accurate the whole way around this supposed globe, this maths. So how's that for a mind blower? And it throws open the whole lid of in discussion. And I'm one of these people that's been out there pushing the 8 inches per mile squared. So I'm not calling anyone out for having suggested that this was the right number. It does make me wonder whether the Robotham Bedford Levels experiments and so on were designed in as disinfo to reinforce this 8 inches per mile squared thing, and to minimize the amount of curvature that should actually be there. Because if it's 8 inches or 1,000 meters, we're talking a massive, massive difference. How about that? So there you have it, folks. Is it 8 inches per mile squared, exponentially growing away from the point of the observer, which is again a very relativistic way of looking at this? Or is it an equal amount of curvature drop? No matter where you stand, no matter where you travel, there is always, it's a football, it's a globe, it's whatever, there is always an even amount of turning, of drop, no matter where how you travel and what direction you travel in. Okay, so that needs to be accounted for. and it's going to make a lot of people feel uncomfortable, perhaps. But you know, the truth must out. And if it's 0.6 of a mile per mile of travel, we need to rewrite our books. We need to rewrite our tests. We need to reevaluate. So I'm hoping some of the big maths boffins, you know, and experimentalists are going to hear this video, are going to give me some comments, feedback, and get involved in the discussion. Tell me where I've got it wrong. But think about that. From the 99th to the 100th mile, is my plane, ship, train going to descend 132 feet? Or is it going to travel, is it going to go down 8 inches? Because someone standing at the 99th mile would have to say, it's only 8 inches from me. I know why we've always argued for the 8 inches per mile squared, because we know that by the time that we've traveled 6,000 miles, 250 miles, we needed to have descended by 4,000 miles. Or, as we say, we got it right, accurate up to about 1,000 miles. Well, accurate as to what, you know, because the amount that we see, we don't know that it's 8 inches. Now I'm saying I think it's over half a mile of drop in the mile. So apply that to a globe, and you'll see that this globe of 24,000 miles, you'll see that the maths will work for you to get the right amount of drop, you know, in the maths, in the amount that you need to travel. So this is Trinity 4. aka Dave. I hope that's useful. It's 0.6 of a mile, friends, for every mile. We've been lied to. No surprise there. But let's see if we can bring this one out, because if we can bring this one out, it'll shatter those ballers, those folks who are saying, there's no 8 inches per mile squared. Well, okay. Is there a 0.6 of a mile? Are we ready to recalibrate? Let me know. Cheers.